is a typical or a common constrained optimization problem where we have the utility as a function of x and y with a log utility function, and we have a budget constraint. So from this, we would write our Lagrangian is equal to our utility function plus lambda, and then here's our budget constraint. Now in Econ 380, or in first semester of Principles of Micro, we learned that the optimal value of x is there's a shortcut method where we go something like this. Sorry, let's check this. This should not be 3 here. This should be 5. So twice the income 5x, and this is 5 times py. And the general form of this comes from, if we call this a and this b, then x star is equal to a times I over a plus b times px. And then we get y star is equal to b times I over a plus b times py. So that's the general format, and that's the shortcut method. But let's go ahead and walk through the steps of why this is true. So if that's our Lagrangian, let's go ahead and take our first order conditions. Let's do it first with respect to x. So here I'll get 2 over x minus lambda px is equal to 0. Let's take the first order condition with respect to y. I'll get 3 over y minus lambda py equals 0. And then the third first order condition with respect to lambda is the budget constraint. Now with this one is we're solving for our x, our y, and our lambda. So those are 3 unknowns, and we have 3 equations. So this system of equations is identified, and we can solve from there. So the way we oftentimes solve it, there's many ways you can do so. One strategy is to solve each of these for lambda, and then set these equal to each other and go from there. So that's one strategy. The strategy I'm going to use is I'm going to bring this over to this side and then divide each of these equations. So I get 2 over x divided by 3 over y is equal to px over py because the lambdas cancel out. And so now I get, this simplifies to 2y over 3x is equal to px over py. And now I'm going to solve this for y. So this then means y is equal to 3/2 px py times x. So now I've solved for y as a function of x. I can plug that into my budget constraint. And so now the budget constraint is only a function of x. So now 3 prime is income minus pxx minus py times 3/2 px over py x equals 0. And so this is where we would cancel things out and work forward. So this is income is equal to pxx plus the py's are going to cancel. So I get 3 over 2. Let's make that last one a 2. Px times x. And now I can add those. So this looks like 2 over 2. So now I can add them. So income is equal to 5 over 2 pxx. And now I'm going to solve for x. So x star is equal to 2 times the income over 5 px. And so that's our answer for x star. Okay, once I get that, I can plug it back into the budget constraint. So now the budget constraint for y is we get I is equal to px times x, which is 2I over 5 px minus py, or plus pyy. And now I'm going to solve for y. And so doing, y star is going to equal 3I over py, because those px's will cancel. We'll then go from there. And this is how, and there should be a 5 in the bottom here. And that's how we solve the longhand for this. So when you see a log utility function, the shortcut allows us to jump straight to this step. Or if you're not certain about that step, we can just go through the first order conditions, solve for one of the variables as a function of the other. So y is a function of x, plug it back into the budget constraint, and then solve for each x and y. And there's where we get our solution.